and welcome to another virtual roundtable from Autocar Professional, which is part of our endeavor to connect and stay engaged with the auto industry, especially during the lockdown. Now, today's topic is an interesting one, and it's quite focused one at that. It's on simulation technologies and techniques in the auto industry and the impact it's going to be having on product development going ahead. And we have with us, as part of our panel, we have Mr. R. Velusamy, who is the boss of global product development at Mahindra Mahindra. Now, Mr. Velusamy, or Velu to a lot of us who know him, needs no introduction. He's been the man behind especially the powertrain and the new generation of products and all the products that are coming out of the company. And we've got a very exciting lineup as well. We also have Renuka Srinivasan. She is the Simulia's sales director, India of Dassault Systems. Now, Ms. Srinivasan, she's been in the simulation industry for more than 25 years. And in fact, she's established the Simulia division in Dassault. So thank you very much for joining us. Today's theme, leveraging simulation, basically for accelerated product development. Velu, I just want to get your opening remarks. How is the automotive industry handling product development, in these times of remote working? Also there's a pandemic going on. There's so much disruption. So just your opening remarks on this.
Thank you very much, Hormazd. Really always exciting to dialogue with you, and you will bring out the best out of us. In the COVID times, I wish all of you are safe and praying whoever your loved ones are in hospital to recover very, very fast. And whatever I can do in Chennai, reach out to me. That's personal note for you, all of you. Coming back to in the COVID times, whether the simulation has become more attractive than the non-COVID times, that's one part. And how are we using simulation to the best design of the automobile? Yeah. In the recent challenging regulations, the multiplicity of regulations that are coming into in the new product, the competition bringing a lot of stops into the lower end models, the middle end models, which used to be in the premium models, plus the cost effectiveness, considering all of them. The best optimization that can happen is in the concept phase. And in the concept phase, you don't have the product in hand. And today you are not doing one-dimensional optimization of, I want an automobile that can take me point A to point B. You are considering it for cost. First of all, affordability you are considering. Then you are considering for the performance attributes of 7 attributes, the drivability, the fuel economy, the ride and handling of the car, the NVH refinement of the car. You can see the hatchback performance, the electronics connected car performance. You can see so many things get added. With the multi-dimensional requirements and all of them to its top-notch requirements, simulation is the only way to find the best point among these. And therefore, simulation at the concept stage has become the core requirement today. And COVID helps in a way that you can give the systems to the people and ask them to optimize at system level, subsystem level, component level in simulation, bring it to the overall vehicle level. Distributed simulation effort leads to the full vehicle simulation.
Right. That's very interesting. So what you're saying is it's become quite the core of the fact that, there's so many, development has to be done across such a wide spectrum now, especially with the complexity of modern vehicles and the regulation changes. Absolutely. I think India, we face such a kind of barrage or avalanche of regulation changes, something major every year. Clearly, as you said, simulation is the core. And, I want to turn to you, Ms. Srinivasan, is that, you've heard what Mr. Velusamy has said, that it is becoming more and more critical this day. How do you see the software industry kind of raising its game to support the OEMs in these times?
Sure, and thank you. And I'm glad to be here on this panel with this esteemed two of you over here. And my best wishes as well to all the people listening in to stay safe and take care of their loved ones. I think Mr. Velu brought across a very salient point that the automotive industry have been very strong users of simulation. And over the years, there has been so much of optimization already being done, and the regulations have become, if anything, tighter and tighter. So I think they have all, when you start off with something which is not that well optimized, it's fairly easy to, cut down and start meeting things. But now we are at a stage where for several, maybe decades now, there's been optimization of these components, and now to find a gram here or an inch there is quite difficult, and simulation is very key to that. But coming back to what's happening right now with the pandemic, we've certainly seen both that, perhaps one benefit for us has been the cloud. A lot of people who maybe were initially a little more hesitant on using the cloud are now much, much more open. So we see people both collaborating as well as doing a lot of large simulations, accessing it from their home. And that has helped them to continue to meet product deadlines by doing simulation from the safety of their homes, while still accessing either HPCs in their company or the cloud infrastructure. And this has also helped them collaborate with colleagues. Earlier, we were collaborating with centers maybe in other parts of the country, but today we're collaborating with our colleagues within the same city itself. So I think that has been one thing that certainly has come out. I'd say the other thing that you alluded to is we did see, especially the first lockdown, when the access to even the factories and infrastructure was down, people could not go in to do physical tests. And then the only other option, if you didn't want to slow down your new product development, was to actually increase simulation. So we have certainly seen, not just in India, but I would say we've had, our auto OEMs in Europe and other parts of the world maybe speed up and increase the number of simulations that they are doing to account for the fact that they are less reliant on or not able to do the physical tests at this time. So that was something we have certainly seen.
Right, right. Velu, I just want to turn to you. You talked about regulations being a big challenge, constantly, too many regulations, which I think the whole industry is facing and has to deal with. At the same time, you've got a very demanding customer as well. So, you've got consumer expectations. It's fuel efficiency on one side, there's ride and handling, there's performance. So, how do you handle all these sort of sometimes very conflicting requirements of consumer expectations as well, in the product development process?
I think you have scanned through the minds of PD engineers. So the single most, let's say, enemy in the product development engineer's mind is the weight. Because the moment you put 1 kg of steel, then you are putting 150 kg of 150 rupees of cost into it. The moment you put 1 kg, then you are allowing the Newton to act on it. The acceleration is nothing but force divided by mass. F is equal to ma, mass into acceleration. The customers do not want mass, but the customers want acceleration. And the powertrain job is to provide force. The force divided by mass is the acceleration. So unfortunately, the customer does not want an affordable vehicle, so therefore lower mass, and wants an acceleration, therefore lower mass. But the engineers, customer also wants a durability, right? Engineers have to meet the crash, and engineers have to provide the comfort, and engineers have to provide the seating space. So therefore, they end up in adding weight to the BIW, weight to the seating system, weight to the crash barriers in the front, and weight to the suspension components, Then as you keep adding the core BIW weight, you have to break the weight because you are accelerating, therefore you have to break you have to save somebody, you have to save yourself. The more the weight you add to the core, the more the braking system specifications would be, and the more the steering system specifications would be. And all of them put together, the more the engine specification would be, because you have to accelerate the larger mass, correct? So the core starts with the seating systems, occupant layout, the bonnet layout, and the rear cabin rear dicky layout. So the fundamental principle in automotive design that I've learned is that if you have 1,500 kilo vehicle weight, about 350 to 400 kilos is spent in the BIW. Correct? Let's say about let's say 1/4 of it. Yeah.
The BIW. Yeah.
Yeah. Let's say about no, about 1/3 of it. Yeah. Roughly about 1/3. Let's say that 1/3 is not 1/3. It determines the remaining 1/3 of powertrain, and
you have to beef up the systems accordingly for the weight.
All the systems that you attach to the BIW is 1/3 and powertrain is 1/3. That's how I say 400, 400, 400. Yeah, that's how you see it. Now, the simulation topic that you do at the BIW is first and core that you do is for stiffness and weight. So what you need for acceleration, what you need for comfort, what you need for deceleration and NVH refinement is not the weight. The engineers get it wrong normally. Even for durability and crash, what you need is the stiffness. The stiffness is nothing but Newton per millimeter. Yeah, not the weight. So therefore, in order to increase the stiffness, in order to increase the Newton, how much Newton I have to put it on my finger to deflect it by 1 millimeter is the stiffness. If the suspension is pushing the BIW by 1 millimeter, how much road impact has to come to push it by 1 millimeter? That's the stiffness that we talk. People think that I add more sheet metals, more layer, then it doesn't move by a millimeter. It takes 2 kg to move by a millimeter. They add weight. That's not correct. The correct answer is Archimedes found out that if I put a ball into the well, a smaller ball, a dense ball, can have much higher weight. A smaller ball, if I put into the well, a water pond, I experience very less resistance. But I put a bigger balloon, 1/10 of the weight of the ball, but they experience a huge resistance. So it is the geometry that has an importance. In simulation, you can bring that. You can provide multiple different geometries for a lower mass and yet achieve the stiffness. You get me what I'm saying?
Absolutely.
This is where the simulation plays an important role. For the BIW, what matters is the geometry.
Right. So, Velu, that's very, very interesting. I think you raise a very important point. And the sense I get is weight right now is the #1 enemy. Try and reduce it as much as possible, from what I understand. But, you talked about simulation. I want to just stick with you as a way to do it. What about materials itself? Because I'm sure there are a lot of lightweight materials, but they would add costs. So is your approach rather through simulation and clever design and absolute, perfect optimization to reduce weight for a given material? Or do you sometimes think you have to even go for a lighter weight or maybe like a high tensile steel, for example?
So the pecking order, Hormazd, is that first you attack with the geometry. Yeah.
Right.
And then with this geometry, there is a limit. Then I change the material. Because when I change the material, I pay for it. And the availability of that material in India is a constraint, correct? Right. If you're going to high strength alloy steels, then you have to import it, right? So then you have logistics and then availability. And then the vendors are restricted. That basket vendors are restricted. But if you, in the crash zone, the firewall, the crash car beam and the crash tip, if you take in the front of the vehicle where it is frontal crash, you would have a sponge-like crash tip that crashes, and then you would have a very, very hard material that does not deflect the occupant. So there you will put a lot of new materials with the geometry. So the geometry and material you will put. For example, on the floor, you wouldn't put a new material. You will only work with the geometry. So it depends on the location in the car where you will put a geometry and a high grade material and a medium grade material and a standard grade material. It depends on there. But the first is the geometry, then the joineries. How you join the A pillar to the roof, how you join the B pillar to the roof, to the bottom floor, how you form the bottom floor. The joineries have significant contribution. The joineries can be analyzed through the simulations, number of welding points, the structural sealant that we use to adhere the different steel layers into forming a single layer. What you see outside is a bulk B pillar on A pillar, but they are all formed with several steel layers. And if they are not properly adhered, you are not going to get the strength. So
Right.
the sealant length, structural sealant that you use, the number of welding spots. Earlier we were using 3,000, 4,000. Now 2,500 to 3,000. Now we are using 7,000 welding spots. Wow. Because you make these uniform. This where to use the welding spot, it is very difficult to decide in a 3D space of the vehicle. It is possible in simulation where the load paths are coming. There you want to have a very dense cloud of weld paths. Where the standard loads are coming, you want to have a very less spread weld spots. Where there are no loads, you just have the structural sealant,
Right.
So
right.
the decision where to use what kind of number of welds is coming from simulation.
That's amazing. And, with that, thanks, Velu, for a very, as usual, very impassioned kind of explanation. I think that's why it's such a pleasure to have you. Just your clarity and the way you explain things is really, really fascinating. Thank you for that. You really raised some very, very valid points, in product development. And with that, I just like to turn to Mrs. Srinivasan. Mrs. Srinivasan is very clear. Velu has said that, with materials, you can only do this much. And there are limits on materials, there's cost, there's logistical issues. But really the way to get the balance of stiffness for crash, getting the weight right is down to simulation. So just from your point of view, after hearing him, does this, from your point of view, is this a really very, very critical part of product development that, you can contribute with, and how are you all doing this?
Sure. No, thank you. And yes, I think it was really nice to see the appreciation of the impact of both simulation and what the engineers have to deal with. Because, like I mentioned earlier, this is also a product which has been in existence for a long time. And I would say, what he said is very true. What simulation companies do is allow this understanding to be put in a manner. And these days, we also allow that algorithms can drive it. Because just to take that point, he said about 7,000 welds. If you're having 7,000 points, you really cannot expect a bunch of engineers to come up with that. And what if you wanted to study the variations in that? Where should you have a certain, where should the spacing be less? Where can you get away with the, larger spacing? How do you look at those kind of what if scenarios? And that's again an area where not just simulation, but, the algorithms we drive to look at what we call the design space. What are the possibilities? Why not go through all of those different possibilities, maybe drive that based on past data that you might have, and then come up with what would be a better spacing. The other thing that I would say is he spoke a lot, very rightly, on, geometry, material, mass. We spoke a lot about strength and stiffness, which are very critical. The other thing that ends up happening is some of this geometry has an impact on your fuel efficiency, right? Your external geometry is what catches maybe the buyer's eye. The consumer wants to see a certain look and form and helps that in deciding. But some of that has an impact on your fuel efficiency. And similarly, what ends up also happening is in weight saving, when you reduce a lot the the thickness of a component, you also could start having things like noise come in. And there again, a passenger experience for a consumer, that becomes an irritation. And today with EVs, that's become even more critical because we are now looking at something which is very silent, and perhaps components or noises that did not matter in the earlier stage are now becoming more and more relevant. And I think what simulation really does help is in exploring more options, and finally in looking at a trade-off, because there is no one right solution, in which case all of us would have perhaps arrived at it, right? It's a trade-off for your particular model. What are you looking at? Someone at the top has to take a decision that they're willing to compromise on this cost versus that, or that they're willing to that this particular material is worth it because it does help them achieve a certain safety parameter, which is critical for them. So that kind of a trade-off is something that simulation will allow you to explore and hopefully then pass it on to decision makers.
That's interesting. I wanted to, you led me on to one topic which you talked about was EVs, because that's a completely different thing. You talked about NVH issues are different in EVs over there. So Velu, just turning to you, now you've got disruptive technologies, electric, autonomous, all going forward. Now they require, kind of a different knowledge and expertise. So, Mahindra, I know, is now looking quite seriously at the EV space. We were aware there are big plans. But in terms of helping engineers upskill, to handle the more sort of multifaceted or different parts of product development, I mean, what's the kind of, let's say, strategy to upskill the engineers in this regard, really?
But before going into the topic of the upskilling of engineers for taking the challenge of EV, I would like to show one picture of how the world has changed. I hope you can see this picture.
Yes.
Yes.
So what you see is not a mesh model, the traditional CAE mesh model of a car. It is called as a rope model. Can you see that?
Yeah.
Yes.
It's like a rope connected. What you can make out by this time that it has three
like
rings.
a space frame, but it's not a space frame. I know what you mean.
Yeah, you can see three ring structures: the front, middle ring, and the rear ring.
Yes.
And you can also see in the front floor, you can see hatch in and hatch out structure.
Yes.
In the rear, you don't see it.
Yes.
And in that hatch in hatch out structure is well connected to the firewall. Can you see that?
Yes.
Right.
So
yes.
you can see the joineries of these rings, different rings going, different elements connecting to the other elements, bottom to top, horizontally, vertically, in the transverse directions. Can you see that? So what you can do, you can split in. This is called morphing technique. You can use. You don't need to build a 3D model of your car. You can build the car in the load path called rope models, and you can position these rope models, and you can use the ring structure of the top hat, and for the floor you can use hatch in hatch out structure. So what you are mentally thinking is the geometry to take care of different loads, the fundamental of mechanical design you are understanding. In the front, hatch in hatch out structure is necessary because you are doing a frontal off crash. Okay, 40% of your the right hand side tire is, but you cannot strengthen only the right hand. You have to cleverly find out a hatch in hatch out structure to distribute the load immediately to the left side of the frame. How cleverly you transfer to the left side. To that extent, you avoid the damage of the driver side door. Otherwise, the full crash will come to the driver side. So, and you will damage the driver side. So, door, you cannot come out. You will damage it. The hatch in hatch out structure, if you have seen, you push it this side, immediately transfers the load to that side. Okay. These are not present in the old platforms. This is present. The ring structure gives the torsional stiffness, the bending stiffness, and the hatch in hatch out structure transfers the load from the right side to left side to the. This is coming because we have done extensive analysis of the crash, how the crash is happening, and we used some of the techniques. Now, when you use the rope technique and when you use the morphing technology and do the simulation, you can easily find out which element is taking the load, which element is transferring the load. It's very difficult for a human being to imagine and to design it and to calculate. The skill set that you are requiring is not how to model a car, how to mesh a car, and how to do FEM calculation. How to imagine differently, even in the FE world, to do these kind of calculations.
Yeah.
Yeah, this rope-in model, all our new products have gone through.
That's fascinating, Velu, again, as always. And I think what I would like to say is, though Velu will not admit it officially, but I think the next range of products, I think what we're going to see is very high on safety, much lighter weight than before. And I think some of these, let's say, innovations have been used. And but Ms. Srinivasan, before we go on to the EV topic, just taking off from, what Velu very kind of insightfully explained, new innovation, a new kind of approach to kind of, designing, developing a whole BIW, the monocoque, where the loads are. How does it work with the OEMs? I mean, obviously now, they've got a new and a completely different innovative way and approach of, developing an all new platform.
Right.
Do you come in at an earlier stage, or do you kind of, let's say, obviously you would come in as a proof of concept in many ways, isn't it? Just to run all the simulations on the model that they have. So just wanted your thoughts on this. Basically, a company like Mahindra looking at very innovative ways to reduce weight, but at the same time maintain crashworthiness, stiffness, and all the attributes that sometimes are conflicting. So I just want to understand, where do you all come in when they start looking at a different and sometimes off the tangent approach to doing something which can be quite radical as well?
Sure. No, I agree. And I think one point which you raised is, at the end of the day, it is about an engineer and understanding how you want to have load transfer, energy absorption, those kind of aspects, right? Now, the thing is, while I represent the Simulia brand, I'm part of Dassault, which is a much larger company, which touches on different aspects. And I would say that we are present. Luckily, Mahindra is also one of our very large and strategic customers. But we are already present in these kind of organizations across different departments. Yes, we are present in the simulation department, but we would also be present in, say, the manufacturing process. We would be present with conceptual design in the designer place. And I think the biggest thing that we can offer is basically a platform to bring in all of these different people, to have them collaborate. Because especially if you want to really think out, come out with new technologies, while yes, we do have our own technologies, our own material models, etc. But a lot of this, to understand this concept, how is that going to then have an impact downstream on manufacturing, if it's such an idea that you're trying out, or also bringing these changes right up front in the conceptual design. Because the important thing is, a lot of the decisions that you make there have the biggest impact downstream, right? And at this stage, at the conceptual level, you have the flexibility and the freedom to really try out different things and then proceed with the maybe a more detailed structure later on. So I would say that from Dassault, we actually, if I come back to us, with our platform, we basically allow better collaboration. We allow, looking at a conceptual phase with optimization. So what happens if you want to try out these different variations of the ring spacing? What do you see? Maybe you have past data that you want to look at. How can you incorporate some of those? So we work with a lot of the auto OEMs right throughout, maybe when they're conceptualizing their vehicle. I would say even at the requirement phase, when they're actually trying to put down what is their requirement and their ideas for what they want for this particular vehicle, in fact. And then work our way down, simulation, and then eventually you might at some stage get into the manufacturing and other aspects. So we do end up working quite a bit across all of these, and our aim also is to reduce the time that people actually spend, because he brought up a very valid point, and I think especially for young engineers, there is a lot of this, oh, I did this gorgeous mesh and I spent 5 days running the simulation. But at the end of the day, if you don't know how to interpret that result, if you don't have an idea of what you're looking out of it, then the point is lost, right? Because the whole point is to interpret, see what you learn, and use that to develop a better product. And I think what companies like ours do is, with our platform, we try to make that modeling and simulation aspect much more efficient. We try to make it more efficient to work across multiple scales, because you might be working at a 1D level at some point, but then you might also incorporate certain 3D aspects into that same model. You also look at multiple physics today. I mean, even without EVs, you still have thermal, mechanical, other aspects. So what we try and basically do is to make all of this efficient, to allow people to then focus on the actual engineering product result interpretation. And that's the goal for us.
Interesting. And, Velu, coming back to the question which I'd earlier asked, and I just want to, let's say rephrase that, because clearly, and the way you've been driving, let's say, the product development at Mahindra and Mahindra, clearly it's a people business. I always believe that it's not a technology that makes cars, it's people behind the technology that makes cars. So, again, on the whole bit about skill, let's say, even when you, let's say, have new recruits coming in, new automotive engineers, what do you expect of them? What do they need to know? What are their skill sets? And, given the fact that we are heading into a completely new, let's say, domain, a very disruptive era right now, something we've not seen since the history of the car. I mean, we're moving into basically EVs, autonomous, everything is digital, connected. Again, Velu, from let's say the skill set point of view, what needs to be done, what is being done to kind of really transform them from the traditional way of product development to, let's say, a more multifaceted way of looking at products?
So it's a brilliant question, Mas. Let me put these into three different buckets. So the core BIW of the vehicle, it is undergoing a tremendous change due to the regulation. Yeah, that we have seen it right now. The powertrain, there are multiple powertrains entering into the car. One is the current IC that it has to go to BS6.2, CAFE, and then it still has, even in 2030, if you assume 30% is electrical EV, 70% is ICE. So somewhere you cannot drop that child so easily. So you will have to keep grooming the child, yeah, optimizing the child. So you still need that knowledge. When it comes to electronics, you are going, it's not a bubble anymore, and it is a balloon. It is exploding like from bubble to balloon, whether it is surround view system, blind view system, camera systems, radar systems, ADAS, steering control, brake control, connected car, the integrated IVI, smart core technology, all the mobile technology, the smart processors which are there in the mobile, they are directly coming to IVI. The infotainment, it is not for audio alone. It is coming for voice recognition, speech recognition, companion, emotion recognition, the songs that you display during when the vehicle is. So a lot of electronic stuffs are coming both in cluster in IVI, cameras coming, ADAS, vehicle drive assist controls are coming, adaptive cruise control is coming, those stuffs, several steps are coming. You have basically automated the gear shifting with an automatic gearbox. But now what you are looking at is, can I automate the steering? Can I automate the accelerator pedal, brake pedal, and clutch? Once you have an IAT, then there's no clutch. Then you have a brake pedal and accelerator pedal. You put in adaptive cruise control. It basically is accelerating and decelerating based on the vehicle that is in front of you, correct? So that means you have, in a way, you have automated it. Now what is left of is steering control. And can I do the steering control optimization, automation? I will have the hand, but the steering will be controlled. If I hands free, then I have a doubt. That is the level of automation that is today going in the cars. It's going to come very, very soon. Except the steering, everything will come. Everything will come. It is possible in India. You can drive without accelerating and decelerating and braking. Without you, the vehicle will do on its own. So such control requires enormous amount of data collection, analysis, and giving a error-free system, detection system in your car. So that is one end of technology that people can acquire and aspire to be a best engineer, best expert in that area. The another is the powertrain that we discussed. It can be EV powertrain, it can be a hybrid powertrain, it can be IC engine improvements. Yeah, in these three, it will coexist. Whether we like it or not, this will coexist. So they can put an expertise into EV area, plug-in hybrid area, or a standard hybrid area, or an IC area. So they have a future for it. So they can develop here. The structure that we have discussed about the suspension, dynamics, CG, the lateral acceleration, forward acceleration, the weight, stiffness. If you are a good engineer in structure, if If an imagination comes to you naturally, you think about the rope model that I've shown, you are good in machine design, you pick up this, the structure part of it. In all three areas, the weight and crash is putting enormous effort on the structure area. The EV migration is putting enormous effort on the powertrain area. The electronics, self-driving, connected car is putting, the bubble is becoming a balloon in the electronics area. So in these three areas, we have enormous amount of opportunities. When I joined, it is only engine, rest is sheet metal. But today you have multiple opportunities.
Wow.
And you can skill yourselves in any area and then pick up what suits best.
You're right. And as you rightly said, it's the whole electronic side, which has just become a balloon. It's about to explode. And there's so much, as you said, and that the level of automation that, the electronics will require to deliver a fail-safe system, absolutely mind-boggling. And, Ms. Srinivasan, I want to, you've heard what Velu said, there are different challenges right now. I mean, even in simulation, do you feel also for you all there are challenges in applying your technology to newer domains, even newer materials, for example? I mean, here there's this whole, let's say the whole electronic side, the autonomous side, ADAS, as Velu was saying, adaptive cruise control again, which is part of ADAS. But the whole ADAS bit is now, going to explode, and it's becoming more democratized as, let's say electronics get cheaper. These suppliers kind of make them more commoditized in that sense.
Sure, no, I agree. And I think it's a very exciting time to be an engineer in the automotive industry. It's exciting because, like you said, there are a lot of new opportunities. On the other hand, it's also quite frightening because all of these new things are there, but with shrinking product development time. And there's a lot of scrutiny as well on this industry, right? I would say we do a couple of things. And I think the one big, shift perhaps that I see a lot is on the learning side. Maybe earlier when we thought about education or what do we do about, knowledge, we typically thought about maybe young engineers, people in college, people just come out looking for a job. But I think today we're very, very clear and have been, I would say, for several years now, that it's basically a continuous learning process. Right. And to remain in the market force, to be able to adapt to all of these changes, there is continuous need to upskill yourself. And so we obviously provide a lot of e-learning content. The other thing is, of course, while they used to be instructor-led and there continues to be some of that, today, especially with the younger generation, but even otherwise, people want to learn at their pace and at their time. So there's a lot of, I would say, 3D experience education-related videos, workshops, hands-on demos, over 1,000 different learning components on particular topics of interest to people. So while some might be on core, what is viscoelasticity, what is, hyperelasticity kind of materials, but there's also on actual industry practices, industry processes, because continuously people need to keep remaining in touch with what is there. The other thing is, even if you are expert in your domain, you need to have some level of understanding of other domains to be able to do this kind of a trade-off collaboration with others. You have to be able to speak their language to be able to reach a common understanding. So there's a lot that we actually do to help people remain continuously in touch with the latest technology. And I think at some stage, if your users are interested, I hope they can reach out. And our, website does have a 3D experience edu, which they can go to and look at the kind of learnings that is possible. The other thing I would say is for anything starting new, you have to start with the simplest that you can think of, comprehend, validate, and then add a layer of complexity. And that layer of complexity needs to, again, get validated before you add something more. And this is the process that people have used for ages, and we help people do that, because if you're working with a new material, you're working with something new, you need to validate slowly, step by step. And while I would say large OEMs and people with that experience already understand this, we sometimes see with smaller suppliers, they realize they have a big leap to take they want to do R&D, they want to come in, but you can't start by putting everything where you don't have experience right into the same, system and then clicking a button. I think this is the disadvantage sometimes of simulation and software. It's very easy to set up a problem, but then you have to understand what you're putting in and what you're getting out. And so I think we definitely believe it's important to put that nuance layer by layer, validate, and then add the next one. So I would say that is certainly there. And I think the last would be to leverage the ecosystem, especially
I think she. Yeah, I think. Yeah, I think Srinivasan, I think your audio is a bit weak. Yeah, yeah, I think lost you. Let's do one thing. Velu, I just want to quickly turn to you because I think we've lost Srinivasan. Yeah, sorry. Yeah, we've lost you there. Your screen is frozen. So let me just jump to Velu because there's one before I ask the wrap up question. Yeah, Srinivasan, we are having a problem with your audio right now. If yeah, sorry, yeah, we lost you there. Maybe.
Yeah.
Yeah, no problem. But I think we got the gist of it. But I just want to turn to Velu on this, and before the final question is, this whole, let's say, working now closer with the suppliers, because Mrs. Srinivasan raised a valid point that there's a lot of complexity in new technologies which need more and more validation and fast validation. So, in working with the supply chain, both in terms of expectations, their responsibilities, how is this relationship panning out? Is it a much closer, let's say, working together, or are you even looking at some level of vertical integration, which some of the OEMs are also looking at in certain parts? So, just wanted to get your sense of the whole OEM supplier relationship in this new era which we are going through.
I think that's another brilliant question. I am not very sure that OEM will try to vertically integrate some of them from suppliers. The simple reason that the complexity at OEM level has increased multifold, with various requirements of regulatory and then multiple powertrains, multiple vehicle norms, crash norms, fuel efficiency norms, and so on. So the effort that OEM has to put in to bring in a new vehicle is very, very high. And therefore, we are going other way around, that you have one side, you have a consultants who can help us to get a right thing in each system and subsystem and component. And then another side is consultant come suppliers who can also do engineering, who can also do design and development and productionize. We are going to these suppliers at the component level. And in fact, we are asking the suppliers to put their team at our engineering location, make it as an extended team, not exactly a co-located team, located in a single room, but located in a single place, that you have a direct access and direct communication with the resident engineer of a supplier. That we have followed this model for the last 2 years, and it's working out brilliantly well. One is that you get a supplier for the component level, and then you get a consultant at a system level and subsystem level, and then overall vehicle level you want it. Second is, how do you reach out to the CEOs and CTOs of a supplier community, and then tell them that this is what I want to do in this vehicle, and this is what I want to reach out, set benchmarks to the industry when I launch this vehicle. What are your thoughts? How do you want to bring in new changes into your component and subsystem and system? Then they come in with different ideas, and they also motivate their teams, inspire their teams. And they also have manufacturing and supply chain and purchase teams, Those teams also have to be challenged to get this technology, because getting a new technology in is a standard technology is easy. The operational level person comes to you, he will offer, you take it and integrate, but you will get a standard vehicle at the end of the day. But if you have to get a cutting edge technology, beating all in the market, then you have to do differently. And the effort required to reach out the top 10, 15 suppliers, engage them for 3 years in the product development, engage the consultant, engage the software tool providers like the Dassault System. We extensively use it for our aerodynamic analysis and structural analysis and CAD modeling. Now, if you have to use all of them, you have to bring in together, and it's a massive cooperative effort to bring one vehicle out.
Wow. No, that's very interesting. In fact, Ms. Srinivasan, you heard what Velu said. Going forward, he's looking at an even deeper and an even closer relationship with the supplier industry. So, from your point of view, I mean, how do you find this? I mean, do you also find that, the way forward is really even more closer sort of integration with the OEM?
Certainly, I think working with the OEMs allows us to understand, much better on their needs and how we can actually also make sure that the simulation addresses the challenges that they face as well. There's a lot of R&D that we sometimes take into account based on the feedback, and sometimes even working with certain OEMs on a particular area. And when it comes to suppliers, we've worked with them. Of course, many suppliers already use us, but we try and ensure, like I mentioned earlier, again, there's a question of leveraging the ecosystem, and certainly in some cases, leveraging the OEM to reach out to their supplier, because like Mr. Velu said, that's a very innovative way of approaching the supplier and making sure that everybody in that supply chain are aligned on, what is the end goal. And that is again where I think things like the collaboration, ensuring it's a certain kind of best practice and tools which are being used, ensures there is confidence from different people as well in what is being done and delivered from an engineering viewpoint.
And last question, which I'm going to ask Velu is, at the end of the day, it's all about investment and money. And, in terms of budgets, I mean, how does the cost impact value delivery kind of be put towards the board or the absolute let's say people who give the funds at the end of the day? I mean, is something like simulation also get discussed, how it can get more leverage? I mean, what's the general thinking now in kind of let's say deploying budgets and for product development?
Yeah, simulation definitely gets discussed. The reason is simulation is like a brain. At the concept level, it is the simulation with which you test the whole investment that you are going to put. Today, you are not building prototypes and then going for tooling later on. You don't depend on a prototype, because that time phase of 7 months, you have taken it away. Otherwise, it is 55 months before you anything think of earlier days, to get a product. Now we are talking about 36 months to 40 months. In 36 months to 40 months, 20 months you really need from the tooled up vehicle to productionization. Now, then you are left out with only 20 months. In this 20 months, what you depend is only simulation, and benchmarking, and best expertise that you come in. Now, the simulation, you can do the work in 20 months, but it also determines maybe out of 100 rupees, 20 rupees is going to this part of the work. For example, the 80 rupees that you put it to the component development and manufacturing and all this, they are not the core drivers. They are the outcomes of this 20% of the money that you have put in. It is more of what is the quality of the software that you are going to use, what is the quality of expertise that you are going to use, because this 20% determines your future and the rest of the 80%.
Wow. Yes.
Yeah. So it has a huge significance. You might have a 70 kilo weight, but the 2 kilo brain determines the 70 kilo body how to behave,
Right.
And in terms of gravity, this 2 kg is 200 kgs,
Right. No, well, Velu, thanks for that. I mean, clearly, I know weight is one thing. I can see future products being much lighter because you've got a single-minded mission to kind of lightweight, for one example. Of course, other technologies and well, but I'd like to just wrap this up and say it's actually been a fascinating discussion on what is such a technical subject. Very clearly, as you rightly finally pointed out, Velu, that simulation really is the key to faster product development for, let's say, a truer product at the end of it, making sure that, what you are planned, you get it right first time. That is absolutely critical. That's what simulation comes in for. And of course, the other obvious advantages of cutting product development time and eventually costs as well. So thank you very much, Velu and Ms. Srinivasan, for joining us. Really appreciate it. And thanks for that.